Hello, this is Eric Devereaux, and welcome to another video in the series about my textbook, Methods of Policy Analysis. Today we're going to be talking about Chapter 2 in the book. I'm going to share my screen just for a second here so you can just see the front page of Chapter 2, which you should now be looking at. Chapter 2 of my book is on the topic of back of the envelope calculations. And the reason it's positioned here in the textbook is because these types of calculations are ubiquitous in the approach to policy analysis that this book takes. Methods of Policy Analysis, the book and the courses I also teach based on this book, are for people who have to do rapid turnaround policy analysis, often unexpectedly or unplanned, not long-term studies that may take years, involve the collection of large data sets and elaborate statistical analysis. Instead, the type of analysis where your client or your boss contacts you with an urgent request to do an analysis and come back in a relatively short period of time with some findings, some recommendations, some insights. And one of the most crucial tools that I find is useful for this purpose is a back of the envelope calculation. If you've never encountered these before, but named that way, you certainly have done them when you found yourself scribbling on a piece of paper or working on a computer very quickly in a spreadsheet or some other format to try to figure out something about numbers in our world that you need to know right away. And that's what this chapter gets into, because if you read the book, you find out that I use back of the envelope calculations throughout the book. So let's talk about them. I'm now going to switch my sharing to a different device. And this is the device that allows me to draw for you. So I'm going to use this device now to draw for you as we talk. All right. So first off, so we are talking here about back of the envelope calculations. Back of the envelope calculations. That's where it gets its name. The BOTEC, back of the envelope calculation, is a BOTEC. And these are done all the time by policy analysts, and they have a variety of purposes. And all of this relates to a really important concept that I advocate in this book, and I also advocate to students in policy analysis, which is numeracy. Numeracy is the equivalent of literacy, except it regards numbers. One of the things you need to be able to do in the world of policy analysis is work with numbers. And numbers have to become puzzles that you unpack, solve, manipulate, build with, play with, interrogate. I think interrogate is a great word to use with regard to numeracy and numbers. You want to interrogate numbers and ask them what they're about. You do not accept them as artifacts. You accept them as something that needs to be figured out, in some cases confirmed, in some cases disconfirmed. Back of the envelope calculations are calculations that you do with a minimal amount of information and a lot of reasoning to try to figure out something useful quantitatively that you need to know right away. Quite frankly, when many students first encounter this approach, they think it is superficial and that you're sort of just pulling numbers out of thin air and doing things with them. And they crave sort of in-depth studies backed with lots of expertise. But the blunt reality is that for most people in the policy analysis field, the requests to turn around some form of analysis come in with a very short time frame attached to them. The client or the boss needs an answer in a day, 2 days, a week, maybe a month at the most. And this just doesn't give you time for that type of in-depth research. There are organizations that do that. Their timescales run sometimes over years. They are involved in sort of the long game of public policy, which is not the game you're most likely are involved in if you are reading this book or taking a class that uses this material. So back of the envelope calculations are a crucial tool because, among other things, back of the envelope calculations can push you to do online research, seeking information in a very targeted and directed way. And one of the things that can go horribly wrong with the internet is just throwing yourself into a search without a purpose. And in the case of policy analysis, you need to have a purpose, a reason for seeking a particular number or set of numbers, and what you're going to do with those numbers. And if you work with back of the envelope calculations, what you end up doing first and foremost is figuring out a formula for what it is you're trying to calculate. The formula identifies the quantities that you need to know to do the calculation. And then that drives your search out into the wild and woolly world of the internet to try to find those quantities and figure out which of those quantities you trust the most, which you trust the least, and other related issues, which I'll go into. Let me just do an example back of the envelope calculation for you right now, one that I actually have used pretty frequently to torture friends and relatives and who are involved in social media. So I know people who claim that they are actually um, actively subscribed to or otherwise engaged in 1,764 Instagram accounts, that they are following, for example, 1,764 Instagram accounts. You see numbers like this all the time when you look at Instagram accounts. How many people are you following? I'm following 1,764. Isn't that great? Well, let's take a look at this in two ways, okay? And for those of you that have been involved in the past in social media, this may make you grimace a little bit when you think about it. But first off, a week consists of 168 hours. Let's say that you only are awake for half of those hours. That's probably not correct, but we'll go there. And that gives you 84 hours. That gives you 84 hours of wake time. And if you multiply that times the minutes in an hour, you get 5,040 minutes. This is sort of your productive time during the week as an estimate. Maybe on the lower end, some of you probably are not getting 12 hours sleep, but maybe you're doing things like eating and other sorts of things. So we'll still stick with this 84 hours as reasonable. And then, of course, all we have to do is take that 5,040 minutes and divide it by 1,764 accounts. And that gives us approximately 3 minutes per account. In other words, if all you did during your waking hours where you were not eating or otherwise engaged, when you basically should be working in some format, it would take you could spend up to 3 minutes on each one of these accounts during your week. Okay, that's one way to look at it. But of course, that's not actually a good view because we're not doing that. Let's ask a different question, a different way. So we have our 1,764 accounts. And let's say that the most that we can give any account on average during the week is 30 seconds. Okay? So we can give it 30 seconds of our time. Okay? And that works out to 52,290 seconds total. Okay? And if you divide that by 60 seconds in a minute and 60 minutes in an hour, what you get is approximately 15 hours. In other words, if you had 1,764 Instagram accounts you were following, and you were giving each one of them 30 seconds of your week, that means you were devoting 15 hours of every week to just looking at the accounts you follow on Instagram. Now, of course, that's not the way reality is because many of these accounts are somewhat inactive and don't post all the time, but you get the point. And the ultimate point here is with this back of the envelope calculation, this is one way to realize that much of what goes on in today's social media is pretty much fake. People are following accounts that they are never looking at. It doesn't mean anything to have followers because they're not paying attention to your content. You have no idea if you're reaching anybody. There's only a handful of celebrities on most social media platforms who we know not only have a lot of followers, but their followers are actively consuming their content. And in most other cases, it's basically just performative periphery and doesn't really mean anything. And you just get there very quickly by just doing some simple calculations about what it means to be claiming to be following all these accounts. It doesn't probably mean anything. I personally, just as a matter of advice, I only follow a handful of accounts. I check on them frequently. I follow them intently, and I don't follow any others because I don't have time for that. And I will not follow an account that I don't have time to pay attention to. That's just the way it is. Okay, moving on. Let's talk in general about what you can do with a back of the envelope calculation. Okay. Um, so let's talk about uses of BOTEX. Give me 1 second here to set this up for you. Uses of BOTEX. Okay. So first off, um, uh, it's very useful to try to figure out what are the minimum and maximum situations. How bad could a problem be? How good could a problem get? What is the range, right? Ranges are incredibly important, especially if you pay very careful attention at the ends of those ranges to make sure that you don't delude yourself into thinking, oh, it could never get that bad. Sort of along the lines of, the Titanic could never sink, right? Sinking is not in the range. Well, no, it was in the range. It was completely possible that it could sink, right? Um, or how good could something really get? What's our best case scenario that we can envision here, our maximum case scenario that we can envision? And are we convinced that that is in fact true? One of the defects of the No Child Left Behind policy, the K through 12 education policy championed by the George W. Bush administration that still has lingering and lasting consequences in the United States, was that it envisioned a world at the maximum end in which every recognized subcategory of K through 12 student would hit minimum standards for completing their grade. That included educationally disabled students. It included students of every demographic category. And the policy was built around that maximum being achievable. And it proved, not too surprisingly, that it wasn't achievable. It was the wrong maximum that was set. And it hobbled what was otherwise, in many ways, a very interesting policy with an unreasonable ultimate maximum objective. Okay. So min-max situations. Um, how about likely costs? How about per capita? How likely costs in total? How about per capita costs? That is per person costs, right? These are some things that a BOTEC can also give you. You can also use it for doing break-even scenarios. How good do we have to do? How successful do we have to break even? We know how much we're spending. We have some sense of the benefits, and where do we have to get to break even? Okay. The book works through some examples here, but I'm going to talk in general about some of the features of most BOTECs, okay, and the formulas are behind them. So let's take, for example, likely costs, right? Or let's take example total cost analysis, right? Well, at the end of the day, especially if we're talking about the total cost that we're spending on units, for example, people. Uh, it could be children in schools, or it could be workers in their workplace, or it could be any other similar unit that you're working with. It could be miles of streets, or the number of bridges you have to repair, anything like that, right? Total cost boils down to a very simple formula, which is unit cost times the number of units equals total cost. So the point is you build this formula first, and then it tells you what you have to try to figure out, what numbers you have to pull. What is the unit cost? And what is the likely number of units? Now notice, if you have a range for both of these, then you essentially have a multidimensional situation where you have what happens if we have the lower number of units and the lower cost per unit, then a mixed scenario all the way up to a high number of units and a high cost per unit. Okay? But having this formula right away gives you the things to focus on. Per capita cost, right, is basically the reverse of this. We start with total cost often, and we divide by the number of units, and we get per capita. And there may be lots of other things that we have to estimate to put this all together. And my book chapter has example after example of doing that, where you put together the different pieces. There is, for example, in the book, the case of trying to estimate how many qualified health workers would have been necessary during the COVID pandemic, early in the COVID pandemic, to actually test every American, every person in the United States for COVID in a drive-by testing situation where you went there in a car and you drove up and they did a swab and then you left. And it works out to be more than 100,000 workers would have been necessary. Highly trained workers would have been necessary to do that and cover the entire country for rapid COVID testing. And you can look at that example, which is based on how many minutes it takes to test each person and how many minutes a qualified worker could be expected to be on the job during the day, and how many people would have to be tested, and the number of people being tested and the time it takes to test gives you the total of time and total that you're talking about. Then you talk about the total of time each worker can do. You do the division, you come out with more than 100,000 highly trained workers would have been necessary in the medical profession to have done rapid COVID testing across the entire country, just as a calculation. Um, and so these are just examples of things that you can do with a back of the envelope calculation once you have your formula. And then you go searching around online to try to find some specific numbers that meet your needs. And I'll let you look at the chapter 2 of my book. And again, I will put in the description of this video the link to the book online. But I want to just finish this particular preview of it with 2 points about presenting numbers to others when you're doing a back of the envelope calculation. Number one is round up, right? Do not be overly specific, or sorry, overly precise. So I've actually had students in my career hand me a number that I think pretty much just came out of a spreadsheet, like this one, like 7,621.47 is the answer. Well, no. If you're doing an estimate, a back of the envelope calculation, or any form of straightforward estimate, this is overly specific. There is nothing wrong at all with saying the answer is approximately 7,600. Okay? So this portion here needs to be rounded away. Anything like this, if anybody sees a number like this, it's developed from quick analysis, you just don't believe it. It's just clearly something that popped out of Excel and was copied without thinking. The answer is approximately 7,600, or maybe it's even approximately 8,000 if you wanted to really, get a little more squishy about the numbers and a little more realistic about the uncertainties involved. But the other thing is, let's focus on ranges, not point estimates. Okay, it's much more important to give people a sense of the range. The range actually is from 7,500 to 8,000. Okay, that is the range. 7,500 to 8,000 is the range. Based on what we were able to calculate here, this seems the most likely range that we would be in. Here's the middle point if you want to know what that looks like. Even better than knowing the range is knowing the shape of the distribution. In this case, I've drawn sort of a normal distribution, but it might be something that looks like this instead, or it might have some other distributional shape. What is the shape of the distribution approximately here, which gives decision makers a sense of their uncertainty, right? Now, this is the most likely range, but the actual possible range could be much broader. And that's important to recognize the true max and the true min, and to think widely about that. And back of the envelope calculations are very useful for giving people a general sense of ranges and numbers. And this might be your worst case scenario. We're going to spend $8,000 per person to fix this problem. And we'll have to build our very conservative budget estimates around that. This estimate is too generous. It's too low. This probably isn't going to work. And that's the kind of flavor you can get from a back of the envelope calculation. Hey, once again, thank you for watching this video. Please do read chapter 2 of my book, which has further examples and more details. And the rest of the book is filled with back of the envelope calculations. And please try to master doing these back of the envelope calculations whenever you encounter a number that needs to be unpacked and treated like a puzzle or something to be interrogated and not just an artifact to be taken for granted. I thank you very much again for your attention to this. And there will be videos posted about additional chapters of this book for you to enjoy. Bye now.